Hi, good morning. Thank you so much for having me here. Good morning to all of you, and very pleased to be joining this inaugural forum. And so my name is Leona Verdadero from UNESCO. I'm really excited to be here and present to you our work. Essentially, when we speak about tech for good, AI for good, this is a very concrete example of what that means, and this is really focusing on resource-efficient, energy-efficient AI. And also just want to preface it, it's really not lost on me that being in this amazing city with so much history with artificial intelligence and computer science. So as a data person and really a data geek, so I'm really excited to be here and looking forward to meeting with you all and discussing all your different interests in this topic. So also would just like to say that the intervention I'm giving today is based on this new report that we just launched in July. So here's the QR code, so please feel free to scan and download and read. I'll just put this up more for 2 seconds and then I'll switch on to the next slide. So just to introduce, so why UNESCO, why we are doing, being engaged in this type of work. So who we are, so maybe you've heard of UNESCO with our work on culture, preserving World Heritage Sites, but essentially we are also the UN agency that's mandated to promote the right to information, access to information. We're a laboratory of ideas, promoting evidence-based research to inform policy. Right? So policy where we work with 194 member states, primarily advising governments or key stakeholders or regulators, policymakers, parliamentarians, where we're promoting inclusive and rights-based approaches specifically to digital and AI transformation. We also do work on standard setting, so perhaps many of you who work in the AI space have heard of the 2021 recommendations on the ethics of artificial intelligence. So concretely speaking, how we develop and deploy these tools must really be grounded in ethical foundations and underpinnings. And so with respect to how we work on AI and the environment, we work on this from kind of a double-edged sword perspective. So on the one hand, we're very much interested in how we can harness really the benefits of AI to advance climate solutions. And on the other, especially with generative AI, we're also seeing the growth in computational power also means more need and demand for resources, which I will show in the next slide. And also, with respect to the nexus of our work in promoting access to information, being a laboratory of ideas, and also promoting information integrity. So we have these global initiatives, such as the Global Initiative on Information Integrity and Climate Change. And so just to, by way of introduction, I think many of you here, I would assume you are the average generative AI user. You've used ChatGPT, Gemini, Mistral, a whole host of, foundation models that you use to maybe support some of your productivity at work, hobbies, recreation, etc. But I think also what we're seeing at the news the last few months, especially, there's really this growing alarm with respect to how, power hungry and water thirsty AI, generative AI really means. So how that looks is, the way we interact with these systems, when we do prompts, you're asking ChatGPT, plan me a weekend in Cambridge, what's a great itinerary? Out of each single user interaction, a lot of that computation is happening at data centers, essentially AI factories. And now we're seeing that, the cumulative millions, billions daily interactions globally with these systems are really starting to take a strain on energy systems and also water. So these are some of the headlines that we've seen over the last few months. It's really growing, calling for more attention and awareness to these issues. And so at UNESCO, what did we do? So with this publication, so this is also research that we've done in partnership with University College London Computer Science. So here it's really the effort to bridge together, research and policy So really, these are the issues that we're trying to address. So we know, yes, generative AI is becoming more powerful, but also more resource intensive, right? So power hungry, water thirsty. So what this also means in terms of access, right? So high resource demand can also risk excluding communities, nations in lower resource settings. So when we say that AI is supposed to be a force for good, accessibility is a main issue here. And so, what we are saying for inclusive and sustainable digital transformation, generative AI must be more resource efficient and energy efficient. So here we're saying that, we have very concrete recommendations on having more smarter, more intentional design choices of how we develop and also deploy these tools and systems. So what we've done, so just to take you through this very briefly. So we ran experiments on an open source large language model. This is Meta's Llama with 3.1 version, 8 billion parameters, so it's still a large language model. We tested very common tasks that many of you have done when you interact with these tools, right? So summarization, summarize an article for me, translate, Q&A. Right? And then under each of those very, very common tasks, so we measure the energy use and performance, so meaning accuracy, right, under different conditions. And here we ran 3 types of experiments to see how much energy savings could we really achieve out of doing these techniques. So the first one is model compression or quantization. So if you just think that, essentially a lot of these models are processing bits and zeros and ones, a lot of data. It's a lot of math, right? And so when you think about it being, in terms of calculating whether you should calculate 3.1415, et cetera, or if you round up, if you actually round up, that makes a big difference to the energy that you consume in terms of the computational power. So this is called model compression and a quantization technique. So actually, that's one way that you can reduce model size. So this can cut energy use by up to 44%, and at the same time, you're maintaining 97% of accuracy. So this is great news. So, first step, model compression, quantization. The second is another thing we're raising awareness on. So we know that a lot of people actually like to interact and talk to their AI models, right? So sharing a lot of information. So one thing that we've also discovered, the way you give your prompt or give instructions also makes a difference with the energy that is consumed. So if I were to be more succinct, rather than giving maybe a 200-word instruction, if I reduce that, that actually also makes a difference. So here we're saying what we've seen is reducing text saves power. So shortening both the input and also the output can cut energy use by over 50% per task. And then finally, we looked at smaller models. But what we're seeing now is, there's a lot of hype with LLMs, large language models, bigger is better. Here, this is something we're really demystifying because what we're seeing, bigger does not necessarily mean better. Smaller, more compact models are actually just as good or sometimes even more powerful depending on the tasks. So here what we're really advocating for is we're saying that, you don't always need a foundational model. So using models built for very specific functions, specific tasks, or in a specific domain, like in healthcare, education, justice, can save 90% of energy used by large general purpose models. So, and in terms of performance, it's comparable and can also even be improved. So, what does this mean? So here we're really advocating for smarter AI for sustainability. So, the key messages are efficiency doesn't mean sacrifice. So small purpose-built models match or exceeded performance of larger ones, and users can save power without compromising quality. And here also intentional use matters. Right? So we're saying current large language models are often, overpowering very simple tasks. So as an analogy, like you're using a fire hose to water a plant, right? Or imagine you're going in the Cambridge library with a very specific question, right? Like you want to know something about botany. So if you're there, you would immediately go to the botany section, not having to navigate all the other sections. So we're also trying to advocate for the same thing. So more purposeful, intentional use of AI also means, the way that we select the types of models that we use. So here, what we're also seeing in the industry, there are kind of these, two shifts. So on the one hand, there's continued investment on, in the bigger is better paradigm, large language models, the race to AGI, artificial general intelligence. But on the other, we're also seeing a plethora of smaller, more right-sized models coming up, and we're getting good signals from the tech players. So we're seeing that they are paying attention and also starting to actually adopt some of these techniques like model reduction, quantization, prompt compression techniques. And so here, so with our core recommendations and also what we're seeing now, it's also quite, inspiring. So looking at IBM, we have here like some headlines from Salesforce and also NVIDIA, again, advocating for smaller models. So we are seeing, some of these very positive shifts from the industry. So still you have the race to the bigger and bigger models, but on the other hand, also trying to make these models more energy efficient and having a focus on smaller right-sized models. So here, so yes, with respect to what we are recommending, so again, design and use intentionally. So for instance, now very concretely speaking, when you go to your ChatGPT, I think you may or may not notice, but you can actually select, there's a mini version, for instance, right? ChatGPT mini or a light version. But the thing is, this is on the users, the onus is on us to make that choice. What we're also trying to do from UNESCO, being a global convener, is trying to get all the different stakeholders and actors on the table, working with tech, saying that, a simple suggestion, can you automate this for the users such that maybe by default, one could start with the more energy efficient model, right? Like the mini version, because you say mini, that's still billions of parameters, right? So meaning in terms of the scale of the model, it's still sizable and for sure will be able to address, general prompts and questions that are, very common to our tasks today. And then also here, we're advocating for investing more in efficiency. And so happy to be here, the heart of a lot of research and innovation in this space. So fund research and partnerships into greener AI techniques. And also here, raise awareness. So raising more, awareness and advocacy also to the end users, reaching out to you. So if there's something that you can remember, so, we also need to see that, every interaction really has a cost in terms of the energy consumption and the water consumption. And finally, here we're really advocating for mainstreaming sustainability. So these sustainability considerations should be embedded across the AI, life cycle and must really start from the very beginning with the way that we design and develop these tools. And yes, so just to wrap up, so in terms of concretely where we plan to grow our work in this space, so now we have the publication. I hope many of you had a chance to scan and download the report. And also what we're doing is in November, we're launching a greener AI tool. So this is really more an interactive tool for the average generative AI users. You can look at different AI models and actually compare the energy consumption and carbon footprint across different tasks. So this is really our way of bringing this information directly to the users. And also at the country level, we are excited to be piloting green AI labs, especially we work a lot with countries in Africa. It's a priority region for UNESCO, and really here is trying to translate a lot of these recommendations in practice, right? So setting up green AI labs in partnership with, local academic research institutes, tech ecosystems to really try and test what these energy efficient AI strategies could mean in different use cases in the country. And we're also doing a resource-efficient AI playbook. So this is really a way to guide policymakers of how to navigate, procurement of AI tools and systems, right, for the public sector, for example. And lastly, because we are UNESCO, we are a global convener, we work with all kinds of stakeholders, so always on the lookout for partnerships and collaboration. And here, Also, we are leveraging a lot of our UNESCO centers of research and AI institutes to really test these solutions, bring these knowledge, translate it into actual country work and pilot applications, and scale impact. Thank you so much, and my contact is here. I'm here the whole day, so please feel free to reach out. Thank you.